Hello, everyone. This is the STEMpump Java course. I hope you guys will enjoy this. Yeah, let's jump right in. So we just want to start. Who are we? What is STEMpump? STEMpump is a student-led initiative that teaches students the best of STEM technologies for free. We cover everything from programming, robotics, to even game design. I know that we have a artificial intelligence class coming up too, so I think that will also be pretty interesting. How does this camp work? So during the stream, we encourage you to follow along with the links that we give you. Feel free to ask questions in the chat, and we'll get around to answering them. If you have more questions afterwards, feel free to reach out to us. So in this camp, we are going over what Java actually is, the structure of Java, how to output data onto your terminal, data types, if-else statements, case statements, and we'll have plenty of examples to come. Does everyone see my screen? Cool. Okay, so let's start off. Hold on, guys. I'm trying to get it so that everyone can see it. Okay. Java is a higher level programming language, meaning that it is easier for a programmer to understand what is going on. There are two types of programming language. There's higher level and lower level. Higher level means that it's basically in English. The programmer can understand what is going on. It's all in different terms, like output and all of that. Lower level means more of binary kind of assembly, where it's not very clear to us what's going on, but it's very easy for the computer to understand. Java runs on something called the JVM, the Java Virtual Machine, which allows Java to run on any device and manages memory stored by Java's code. This helps carry out many functions in Java and basically helps the computer understand what's going on. Java is one of the most popular programming languages out there, as it is used from everything from machine learning to video game creation. And lots of things are made with Java, like Minecraft. So for offline programming, I recommend you download Java. So actually, let's go here. And you can see that there's plenty of downloads. Java 14 is the latest, and you can download Java here. So that's cool. We'll be doing that for offline Java sessions. We're doing online IDEs. So what is an IDE anyways? An IDE means an integrated development environment. An IDE is basically the interface in which a programmer writes their program. It's basically a text format. An IDE lets the programmer edit their code. It also lets the programmer debug, which is basically going and checking for errors, and build their code. The IDE carries out these two important tasks, building and compiling. To build the code is to make a program standalone software, code that can run by itself on the machine. It helps detect errors in the syntax, which we'll learn later on, of the code, and makes the code run by itself. Compiling turns code from a higher level programming language that we talked about into a lower level programming language, such as assembly or binary, that the computer can more easily understand. For offline programming, we recommend Visual Studio Code. You can check out how to download Visual Studio Code in the Java resources section on STEMpump.com. So, anyways, we're going to be using an online Java IDE. So, let's go to stempump.com-r-java IDE. I'm going to post the link in the comments section. Cool. Let's move on. What is syntax? Syntax is basically the structure of our code, or the grammar of our code. That's a better analogy. English has examples of syntax. Grammar is the syntax. For example, the first letter of a sentence has to be an uppercase letter, and the sentence has to end with a period mark. Just like that, Java has some syntax rules, just like any other language. When we refer to the syntax of a code, we are referring to the structure of that line of code. So let's open up our online IDE, and the link should be in the comments section. And this is what it should look like over here. Just gonna wait for everyone to get there. Someone asked, if you were to use an online editor, would Atom still be sufficient enough? If you have a plugin for Java, Atom would work perfectly fine. Yeah, cool. Okay, let's look at this. Public class hello world. Now I'll get into what public class means later, but all you need to know about this is that this basically declares the file that we are in, right? So, we always want the public class in our syntax, and then we want the file name. And this file name right here, hello world, the first letter has to be an uppercase letter. And it's always a good idea that if you have multiple words in your file name, that you also make each word uppercase for the first letter. This squiggly bracket right here, I don't know what it's called. I'll just call it a squiggly bracket. It's an open and closed bracket. And everything that is in your Java code goes, or mostly goes, in here, in middle of these two squiggly brackets. Okay, so what is this public static void main string args? Well, what it is it's basically what we call the main method. Now what the Java JVM does is it looks through every single line of code on this program. And what it does is it says, okay, we're opening the file, the class, hello world, and all of the rest of our code is going to go in here. Then it goes to the second line. It looks at this, and it says, okay, this main method is open. Now, what's the main method? The main method is basically how we use, it's basically most of your code goes in here. Whenever the JVM looks at your code, it'll look for the main method. And then everything in here, in the middle of these two squiggly brackets, will be executed in between those lines. And it'll look through each line that way too. And it executes at runtime. That's pretty cool. Nice. So let's get into actually outputting our code. We can output code by typing system.out.println. And then we have those two brackets and the semicolon. Let's go to our Java IDE, and we'll go inside these two squiggly brackets right here. And we'll type, by the way, it's always a good idea to format your code. So when you're over here, tab over, and then type your code. That is the basic syntax of a print line statement. With that, just an empty print line statement will actually just move your cursor down one line on your terminal. Now let's say we want to actually say something. Let's say we want to go with the traditional hello world. So for hello world, what we would do is we would go inside these two brackets, which is where our output, it looks for our output, and we will put double quotes, and it will say hello world. We can run, which will build, or execute, which will build and compile our code and output it. This will say hello world. Now, this is an important note. You should always put semicolon after your print line statement. That'll tell the Java virtual machine that you are done with using that line or that function, which is our print line function. Now, I know what you're wondering. In this slide, we're talking about print line and print. What's the difference? Well, this is the difference. Whenever we print our print line statement, it is printing the line, and then it is moving the cursor to the next line. So it is basically moving the cursor to the next line. If we just use a normal print statement, or if we copy this and then paste it again, but if we delete this line, print ln, and just do system.out.print, it will simply move the cursor next to the end of the sentence, and it will say, when it loads, hello world, right next to each other. But if we do print line, it will do this, hello world, but on two separate lines, because that ln tells the cursor to move down one, and the next output will print there. Cool. So now we can basically write anything we want. We don't have to say hello world. We can say turtles or cake is cool, and it will print out cake is cool. Another cool part of this print line statement is that you can do arithmetic functions in here. You can say 5 plus 6, and it should print out 11. You can also, You can also print out 5 plus 6 is, and then use this addition sign. And then if we want to switch back to finding arithmetic, we would just use 2 brackets and say 5 plus 6. And now we'll say 5 plus 6 is 11, right here. So this plus sign in the orange is the concatenator, which is basically a way to link different words, strings, and data. Nice. So any questions? Cool. Let's get rolling. You can't get the stuff to go to the other half of the screen. There's buttons right here to expand. I'm sorry, I don't know what you're talking about. Yeah, the code goes on the left side. The result is on the right side in this online ID. So next we're going to be talking about comments. Comments are needed to keep notes in your code. It adds footnotes for yourself and others on what certain aspects of code do. It is important to put notes, especially when you're doing group projects, in which you can let other programmers know what is going on in the code. You can add single line comments, like using the 2 forward slashes, or you can add multi-line comments using a forward slash, an asterisk, whatever your comment is, for asterisk forward slash. Let's see what that looks like. So you add double slash, and then you can just say whatever you want. We want our comments to be useful. So I'll just say the line above prints 5 plus 6. And when you press execute, it will not change your code in any way. All it does is add notes. You can add multi-line comments by doing this. The line, or this line, is a multi-line comment. And it won't do anything to our code. Questions? Cool. Also remember, when you are printing out print line statements, add a semicolon to the end of your code. Okay, data types. What are data types? Data types are sets of data that are assigned values. these values that are assigned have specific attributes that limit what values the data can take. There are many data types, but these are the ones that we will go over for right now. There is an int, which is int or an integer, which have whole numbers 0, 1, 2, 3. They can also be negative numbers. They're just integers, whole numbers. A double is a number which can contain fractions, such as 1.5, 2.6, 3.0, 0.0, negative 3.141592, whatever pi is. That is a double. It can contain fractions or decimals. Next, we have a Boolean. A Boolean assigns a true or false value to the data. It's simple. It's true or it's false. And a char returns a specific character assigned on an ASCII chart. And we'll get into that later. But let's first look at how we can declare these data types. So I'm just going to delete these comments for right now. And we can declare our int. So first I'll go over an int. You name int like that, and then you put the name that you want to assign to your integer. So I'm just going to call this num1. You always want your data type name to have the first letter not be capitalized. It should not be capitalized. And then we can assign it some kind of number. I'm just going to assign it 9 for right now. And that's how we declare an integer. The cool thing about that is that we can now type this out. Okay, so this is our normal print line statement that we talked about before. But now, instead of putting double quotes, we simply put the integer or data type name. So we called it num1, and we referenced num1 in this system.out.println. And now it will print out 9. Right here. That's pretty cool. And we can use the concatenators that we talked about earlier too. And we use that plus sign, which means that after a double quote, we want to add something arithmetic or some sort of data or any other line of code. And we can say this integer is, and then the number. So we can output or run, execute. This will build and compile again. And it says this integer is 9. If we delete the space, it'll look pretty ugly. We don't want to do that. So remember, make sure everything looks nice. Add your spaces. This integer is 9. You can also do the same thing with doubles. So I can rename this double num1. Again, we are assigning the number 9, and we can add decimals. So I can say 9.12, and that will assign to the double named num1. And we can do the same thing and print out num1. Let's go ahead and do that. And it gives us 9.12. Does anyone have any questions so far? Cool. So let's move on to our next. The next data type that we're going to look at assigning. Oh, someone said it says one error. Whoops. That can be anything from you didn't add your semicolon, the first letter of your integer name or data type name is not is capitalized, which it shouldn't be. Or there might have been a typo. So, let's look at Boolean. A Boolean assigns a true or false value to the data. Let's declare a Boolean. Okay, so we can assign a Boolean just like we did a double, but it's a little different since we're assigning true or false. So we can name it bool, short form for Boolean, and we can assign it true. I spelled true wrong. We can assign it true or false. And just like the other one, we can put it in the system.out.print line. And it says true. It's pretty cool. And if we've changed it to false, and run it, or wait, sorry. There was a mistake on my part. You put the Boolean name. I'm sorry about that. Yeah, so you put Boolean bool. It assigns true or false to your Boolean that is named bool. And the system.out.println, we reference bool. And now it will, it'll say false. And if we change it to true, it will say true. That's pretty cool. Anyone have any questions on that? Nice. Okay, so now we're going to look at char. A char returns a specific character assigned on an ASCII chart. Those are characters like A or B. And yeah, so they're basically characters. And so you can declare a char by stating char and then your character name or whatever you want to name it. I'll just call it And this time, you want to assign it with a single quote. So let's say you want to say A. A is your char. And so now it'll print out A. Oh wait, system.hour. A little typo there, happens. And now it'll print out A. That is pretty cool. But let's say you don't want to get this specific return type. Well, as I referenced earlier, you can look at the specific character assigned on an ASCII chart. So what is an ASCII chart? Well, this is an ASCII chart. And an ASCII table will basically tell you what is on your char. So if I wanted to return the value h to char, I would have to figure out, okay, where's h? It is here. And what decimal number is assigned to it? So you look at the DC column, 72. So you can, instead of putting double quotes, Z, or whatever, you can put 72. Or H, sorry, and it will print out H. That is pretty nice. But there's one thing that I haven't gone over, and that is reassigning a data type. So let's say I just have an int. Let's say the value of it is 5. So we printed it out. But since Java reads line by line, you can actually use the same variable to print out a different number, or same data type to print out a different number. Let's say we can put the name right here and say that it is equal to, and let's say it's going to now be equal to 3. So we just reassigned 3 to the integer called num1. And notice that you don't have to put int again, because you're not declaring int num1 again. You declared int num1 right here. You're basically referencing that number and setting it equal to 3. And now we can print it out again. So it printed out 5 when num1 was assigned to 5, and now it prints out 3 when num1 is assigned to 3. That's how we redeclare or reassign the value of a data type. Now, all of these data types are what we call a primitive data type, meaning they have one specific characteristic to them. An integer is a whole number, a double is a number that can be assigned like a fraction or a decimal. Boolean is true or false, the char is A or B, but we haven't talked about others, and we'll talk about those later. Let's go on to operators. So there are operators, which are essential to doing math and assignment in Java. Here are a few. The plus sign will add two numbers in an arithmetic equation. We already saw that. A subtraction sign will subtract two numbers, or ints. A multiplication sign will multiply two numbers. A division sign will divide two numbers. And this percent sign will give us the remainder of dividing two different numbers. Cool. And so, we can use these to perform arithmetic operations. We can make two ints, num1 and num2, and we can add num1 plus num2, and I forgot my semicolon, and it will print out 8 because num1, which is 3, num2, which is 5, will equal 8, and I can do the same with a subtraction sign. I can do the same with a multiplication sign. And I can divide. And as you'll notice, 3 does not go into 5, or 5 does not go into 3, sorry. And so it will just print out 0. It will not print out any fraction. But if we assign these both to double, it will give us a fraction. Because remember, doubles are able to create fractions or decimals. Any questions? And remember, you can watch this YouTube video. You can watch this stream on YouTube again on the STEMpump channel. Cool. We can also do arithmetic when assigning. Here, I'll actually just go back to here. And let's say I want to make a double called arithmet or add. And so we can make that num1 plus num2, and we can print out that. Cool. And so let's see how we can use this arithmetic. We can use assignment operators. But before we do that, let's do a little project. Let's say we want to find the remainder of, or not the remainder, we want to find if if one number is odd or even. So how can we do that? Well, when you try to find an odd or even number, one characteristic of an odd or even number is that an odd number will have a remainder of 1 when divided by 2, and an even number will have a remainder of 0 when divided by 2. Or, yeah, when divided by 2. So let's say this is equal to 4. So we can do arithmetic, and we want to find the remainder of when num1, which is 4, is divided by 2. Well, that'll equal 0. So that's 0. And so we know that's an even number. What about this odd number, 5? When we run this same program again, and we change num1 to 5, it'll print out 1, which means that we know that this is an odd number. Any questions? Cool. Okay. Let's go on to assignment operators. Assignment operators are a way of setting a data type equal to something. We can use an equal sign, which assigns a data type equal to something. So if we were to, like we used, num1 in this other example equals to 5. So the one on the data type on the left side will now take the value of the data type or data on the right side. So in this case, num1 is assigned 5. We've already dealt with this before. Plus equals assigns a data type to its original value plus another value. So if we went here and said num1 plus equals 3. Now we will know that num1, which is 5, is added to 3, and that gets stored back into num1. So num1 is now equal to 8. If we were to print out num1, and print out num1 again, we would see that it changes from 5 into 8. That's pretty cool. Now we can change values without printing num1 equals num1 plus 3. It's just plus equals. Minus equals does the same, but it subtracts a value. Same with / equal, which divides a value, and multiply equal, which multiplies by another value. So if we were to do 6, assign this to 6, and then divide by 3, or subtract by 3. Let's do that first. It'll be 6 before and then 3 after we change it. Same with divide. It's 6, then it's divided, and then put back into num1. So now it equals 2. The same with multiply. So 6 times 3 is 18. That value is put back into the original data type and then printed out at this line. So when we execute this, it turns from 6 into 18. Any questions on that? Nice. Okay, what if we just want to increment a number? We want to add or subtract by 1. Well, we can use this plus operator, which adds or subtracts from the data type that we see here. So let's go back into our code. And we can do num1 plus plus. And so num1 plus plus will print out 6, which is the original value of that data type. It adds 1 to it, and it prints out num1. So it'll go from 6 to 7. And we can actually just keep doing that. So it goes 6, 7, 8, 9, 10, because we're just adding, or incrementing. We can also subtract by 1 using the same increment system. So it goes 6, 5, 4, 3, 2, and then we can do it again. And it will go 1. That's pretty cool. So what are this new type of data? Strings. Strings are beyond a step beyond the data types that we've discussed so far. So far we have looked at primitive data types. A string can be characterized as an assortment of Char data types added together. For example, a string could be a sentence, like a cat said meow. You can declare a string by the same kind of thing. The string, and then whatever the name of your string is, equals double quotes, and inside those double quotes we want to put our whatever we want to say, our sentence. And we want to end that off with a semicolon, because that is the proper syntax. Let's look at that. I'm going to name it sentence. And then we can say whatever we want. I'll say hello world because I want to. That's what I want to assign to that string name. And we can print it out as usual. Using that name, which is the reference. Now it says hello. But does anything look similar? Well, that's because what we've been doing in print lines as far as we've been typing out. We've been typing out like this. Well, this right here is actually a string. And so basically we're declaring the string beforehand so that we can do multiple things to it. Cool. And so that's how we declare a string, and we can put literally anything. I can put a name. I can say an average name, and it'll just print it out. So we can put literally anything in the string. And that is the syntax of the string. Well, along with strings, there are multiple functions. That go along with the string that can be utilized. We can use the char at function that will give us a char at a specific index in the string. And by index, I mean location. We can use index of, which will give us the first index of a phrase in a string. An index meaning the location of the phrase in a string. Substring, which will give us parts of a string from one selected location to another selected location in the string. We can get the length, which will give us the length of a string. And we can do to uppercase, which will give us the entirety of the string in uppercase letters. Cool. So, as I was referring to, an index, think of it like this. A string is a chain of letters. Okay, so if I name this, it is a chain of chars. Think of it like this. It will have one char, which is the H. It'll have the H char in this string, the E char, and this, hello. And so that's basically what the computer sees. It sees HELLO. Well, so an index is basically the location in that string. H, and that string is counted by 0. So if we were to characterize each one by its index, this one would be H. It's at the 0th position in the string. This one is at the E, which is the first position in the string. This one is at the L, which is the second position at the string in the string. This is the other L, which is the third position in the string. The O, which is the fourth position of the string. And it's important to note that strings basically start from 0. They're 0-based counting. Okay, so what does this whole char at index of, what does this index return us? Well, if we were to go back to this, and we were to assign a different string, and this one's just called string 1 because I don't have much of a better name, and then we can see different things. So first of all, let's say what is index of? So index of will return, so to carry out that function, it will return the basically that string. Sorry, there's something going on in the background. And so we can go to index of, and let's say we want to get the char, or sorry, not the index of, char at. Sorry, char at. I want to find the char at a specific position. So let's say I want to find the char at the first position, which is actually the second one. The computer would go and it would look and it would see in this string, the E is at the first position. And we will see that if we were to put this in a system.out.print, it will output E because that is the char at the first position. Is there any question? I know that might have been confusing, but any questions? Great. Cool. Now let's say we want to learn what index of means. So it'll give us the location or index of a specific phrase in a string. So if we go back to our code and we were to make this index of, and we wanted to find the index of E in the string. So it'll go and it'll search the string and it'll try to find where E is. E is right here. And now it will go and figure out what location it's at. It's at the first position. So print out the index of, and that is 1. That's pretty awesome. Substring will give us parts of a string from one selected index to another selected index. So from one location to the other location. So it would go like this. The substring, we would put this parentheses here, and it will go from whatever index. So let's just say we want to say HE. So we go from this, then it'll go and it'll move the cursor to the next one, and then the next one. So we would put it at 2. And it would just go here, because it would go from, okay, this is the 0th position, the 1st position, and then it stops right there at the 2nd position. So it just prints out HE, because this is the substring of hello. That is pretty awesome. Great. Now let's look at the length. The length function will give us the length of the string, of course. So it will go and find out the length of the sentence, and this is the basic syntax of it. Put your string name, and then you put dot length. Execute. And it will print out 5, because there are 5 letters in that word. So that is the sentence length. Any questions on that? I know it can be confusing. Don't be worried to ask questions. Okay. So now we can go and we can do a new thing. We can make the entirety of that string an uppercase. So you can do 2 uppercase, and this is the syntax of that. You put your string name, 2 uppercase, and it will return the entire string in uppercase. And we can also make it 2 lowercase. And now the whole entire string is lowercase. Great. So let's do a little practice with this. Let's say I wanted to find out the name of a person. So I would let's say I just wanted to print out these 2 lines. The first name and the last name. And you just wanted to print out the first name and the last name of a person. We can use these Java functions to figure out the first name and the last name. So I can name it string. We want it to be a meaningful variable name or data type name. And so we would name it string name. And let's say the name is John Smith. Great. A few things that we will need is the length, the substring function, and the index of function. So the length, we can store the length of the string in the int length length. And that we can return name dot length. Another thing that we will need is the index of the space, because we wanted to find out where the break between their first name and their last name is. I'll just call it int space, and that will equal the name dot index of, and we want to find the index of the space. Great. So we can now utilize all of this. So we can make two strings. The first name string, and I'll leave that right now, and the last name string. So what is the first name string? Well, it can be characterized as the substring. Remember, substring gets the string from one location to another location. If we think about this, it will be the space from the name and we would go from the 0th position, because remember, this is the 0th position, and it will be from this first position, second position, third position, to the 4th position. Or actually, because we want to get the index of the space, it would be the actual index of the space. So it would be from there to space. Because this will return the index of the space, which is the 4th position, and then this will find the string from the 0th position right here to the space. Great. And the last name would be the substring from the space to the entire length of the to the end of the program. Great, and now we can print out the last name. and we can print out the first name. Pretty awesome. And since we want it to be like this, we would have to format it. And remember, add that concatenator. And this will print out the first name and the last name. John Smith. We can name it anything. Let's say my name was Java McJava. And so it would print out the first name, which is Java, with the last name, which is McJava. It's pretty silly. You can play around with it. Yeah, so this is the code for that. Any questions? Remember, don't be afraid to ask questions. That one was probably the most complex thing that we've done today. So, how do you make the input? Oh, how do you make an input so that you can change the name of the variable? I'm not going into that right now, but you would use something called a scanner, and that you can go to Java resources on the STEMpump page, and that'll tell you this exact thing, but with input. Right now, we're just looking at how we can use this string to be manipulated. The online IDE does not support scanner, so for that you would need an actual IDE. Cool. Okay, let's get into the next thing. Conditionals. Conditionals are actually ways to check if a statement is true. And so the way that you do this is that if two parts of a condition are true, or if the overall condition is true, it will actually output a Boolean that is true or false. So basically, equal equals checks if the two data types that you submit are equal. Less than or greater than or equal to checks if one data type is greater than or equal to another. Less than or equal to checks if one data type is less than or equal to another. Greater than and less than check if one data type is greater than the other. And that goes into checking arithmetic functions. So how would we use these conditions? And we know that conditionals output true or false. We can actually do that using something called an if statement. If statements help programmers check if a certain statement is true using conditionals and helps us act upon them. Conditionals, remember, will return a true or a false statement if a conditional is true or false. If a conditional is true, the code for an if statement will execute, and if a conditional is false, it will not run an if statement. And this is the syntax down here. So if you want to make an if statement, you make the if, the condition that you are running, So we want to, let's say we want to check if 5 equals 5, right? We would go back here and put 5 over in this part, equal 5, and put that right here. And if that's true, the code in these two squiggly brackets will run. If it is false, it will not run. We can apply this. So I'm just gonna delete this entire thing. You can go back to the YouTube video and check it. And let's say we have two ints, num1, which is, we can say 5, and num2, which we can also say equals 5 for the purposes of this. And so we will put that in an if statement. We will check num1 with num2. And so this if statement will go, if num1 is equal, remember that is our conditional statement, is equal to num2, it will return true to the overall condition. And if the condition is true, this if statement will execute. The code in between these two squiggly brackets will play. And so we can put anything right here. And we can say these two data types are equal. And we will wait for it to load here. It is taking quite the while to load. Okay, and so this will say in num1, it'll declare these two, and if they're equal to each other, which they are, they're both 5, it'll print this out. And that is true. These two data types are equal. Say we wanted to change it. Say we make num2 equal to 6. And we can check if num1 is equal to num2. Or let's actually check if num1 is greater than num2, which it isn't. Num2 is equal to 6, and num1 is equal to 5. So we'll print these two data types are equal. But if we delete that, it won't say that because this if statement is not there. And it doesn't say anything because this condition did not return true, and thus this code did not execute. And so we can do that with greater than or equal to, less than or equal to, greater than, less than. here are the conditionals, and please ask questions if you do have any. So this is the time for questions. Is the else statement used in the same way as a JS else statement? Yes, and that's what we're going to talk about next. Yeah, so a JavaScript else statement is pretty much the same. And so if the first if statement is false, it will then resort to the else statement if we put one. So let's go back to our code. And since this if statement is not true, we would just put an else statement. And we would just put something that is true to the statement, like num1 is less than num2. So as you see here, it says num1 is less than or equal to num2. And if that is true, it will print out these two data types are equal. Okay? But since that isn't true, it resorts to the else statement. And so the else statement will basically be basically the default should the last if statement not be true. And that is the case. And so it printed out num1 is less than num2 right here. And so that's an important way to differentiate things, to add little clauses in your code. It's very important. So if you want to take a quick glance at this, I will leave it here for a few seconds. Cool. Let's move on to else if statements. Or, sorry, there is another question. Is it possible to change an int variable into a string? I believe there is, but I do not remember clearly. But if I remember correctly, there's like a function to do that. That should be on our resources page. Cool. Let's move on to else if statements. So an if statement, if an if statement is not true, so else if statements execute when an if statement is not executed, and if a conditional is proven to be true. So if this is the syntax, and so let's say this is our example. 4 does not equal 5, so this code will not execute. But it'll say else if 5 is equal to 5, and since that condition is true, it will execute. Let's go down here. And we can basically say, this is the syntax, you add an else if your little squiggly, and let's just say if num2 happens to equal 6. We can say in this statement that is used, num2 is equal to 6. And since that is true, it will print out num2 is equal to 6. So let's say if num2 is equal to 7. And we could add something along the lines of none of the other if statements are true. And then it will do that. Any questions? Cool. Let us move on. There's things called nested if statements. And those are basically if statements inside of if statements. This is what it would look like. So taking if and let's say the first condition that we will check is if num2 is greater than or equal to num1. Well, what we would do is that would check the conditional, and that would turn out to be true. And let's say if we want to say if num2 is equal to 7. We can print our own little statement as usual. And we can add an else statement. And so that we can say in that num2 is not 7, but greater than num1. And so since num2 is greater than num1 and it's equal to 7, it will print out num2 is 7. Otherwise, it'll just say num2 is not greater than num1. Let's take a look at an example of this. The useful application would be to change an int to a number in the code. So the user should be able to put in an int, and depending on the number grade, the code should print out a letter grade. So 100 equals a perfect score, a is equal to a 90 to a 99, and so on and so forth. So we can make an int called grade, and the user can put whatever grade they want. We haven't gone over inputs yet, so that's not possible. So we can check if the grade is equal to 100, it'll print out one thing. Else, if the grade is greater than or equal to 90, it'll print out another thing. And if it's greater than 80, it's a B. If it's greater than 70, it's a C. And if it's less than or equal to a 69, it'll equal an F. So we can say and we can print out whatever we want for each one. So since this one is an A, we'd say you got an A. This one would say you got a B. This one would say you got a C. And this one would say you got an F and you failed. So when this executes, it'll say you got an A because the grade is equal to 90, and since it satisfies this requirement, so basically the JVM would look at this if statement and it would say this isn't true, and it'll move on to the next else if statement, and since this is true, it'll output this, and all of these other else statements would kind of be ignored. And so we can change our grade. Say we got a 64. We would have failed. It says you got an F, you failed. If we got a perfect score, you got a perfect score, and so on and so forth. Is there any questions on this? Don't be afraid to ask questions. Great. Okay. So, as you might have noticed, we're dealing with ints, doubles, and other primitive data types the whole entire time. If we wanted to check a Boolean, we could do this. And the code will execute, and it'll say this statement is true if it's true, but it's not, it's false. And it'll print this statement is true. Else, because that statement was not true, it'll print out this. And because it's not true, it is false. Great. So as you might have noticed, we are not checking strings, because for checking strings, we do not use the equal equal. We use the dot equals modifier, because this is not a primitive data type. A string is more complex. So we can use the dot equals and we can type in hello. And the if statement can check if the statement is true. So it'll say sentence dot equals, and you would put the little parentheses, and so this will put the it'll check if the sentence equals hello, and it does. So it prints out this says hello. And if we run this at the execute tab, it says this says hello. That's pretty awesome. But what if we wanted, what if our code, our sentence had a lowercase h? Well, it wouldn't print anything because it's not really equal to this, because this has a capital H and this has a lowercase h, and it says these two strings are different. So how do we solve this problem? We don't want to keep changing the string to uppercase or to lowercase. We can use a simple modifier to this called ignore case. And this equals ignore case function, basically what it does is it just takes the string, compares it to whatever string you want to compare it to, and it will ignore the case structure of it. And as you can see, now it will print out this says hello. That is pretty cool. You can also compare it to other strings. And so you simply, this declares that the string called other sentence says another string, and this will check if it equals, if this equals this other sentence. Since it's not going to execute anything. Or actually, this does not have a semicolon, but it's not going to execute anything. It's just going to be left blank. And if it were equal to the other one, it would execute this says flow. Because that is the code that is executed. What if we didn't want to keep going in between if statements and else if statements? It would be gigantic chunks of code if we just kept doing else if, else if, else if. Because in other pieces of code, the code might not be so simple. This is where we can use case statements. So to basically declare a case statement, you have to get a variable or a data type. I will call it name or num1, and it will be equal to 1. To make a case statement, you would put switch, parentheses, and then these squiggly brackets. And then you would put the number or integer or double in question. So that is num1. And so we can put, in the case that this is equal to 1, we will print out this. And this will equal num1, or sorry, this will print out anything that we want it to be. I will say num1 is equal to 1. And then we put this little thing that's this break. Let's break this down. So we have a switch which will look at a specific double or integer. In these squiggly brackets, we'd say case 1. What does case 1 mean? Case 1 means in case that number is equal to 1, it will execute this code. And once that is done, it'll break, meaning that it'll break out of the switch statement and go to the next line of code that it needs to analyze. We have fault. We have another thing about case statements, which is the default statement. The default statement is basically the else statement, the else part of the switch statement. And so this will go on, and we can make it say whatever we want, or do whatever we want. You don't just have to You don't just have to print, you can also change variables and all of that, is not equal to 1. So it says num1 is equal to 1 because in the case that num1 is equal to 1, which it is, it prints out this. But let's say we change this to num2. It'll execute and says it's not equal to 1 because it's 2. Goes to the case. It does num1 does not equal 1, so then it goes to the default automatically. And then does the code that we want it to do, and it breaks out. Any questions on that? What is the difference between an if-else statement and a case default statement? There's not really much of a difference. It's just that it takes less space in computer memory, and it's much cleaner code to write. Yeah, that's basically the main difference. Else if statements, so this will just be an if statement, and then if we were to add another case, that would be the equivalent of an else if, and then the default is the equivalent of an else statement. Cool. Now we'll go on to our last subject, which is Boolean logic gates. Boolean logic gates help us with a wide variety of conditional cases. The AND logic gate checks if 2 conditions are true. The overall condition will be true if both conditions are true. The OR logic gate checks to see if one of the multiple conditions presented are true. The NOT checks to see if a condition is not true, and the XOR checks if 2 conditions are different. So those are the basic logic gates. This is how to use AND. Let's say I had an if statement called num2 and it equals 3. In the if statement, it would basically go and check, okay, if num1 is equal to num2, or is less than num2, let's say that, or equal to, and num2 is equal to 3. The code in here will execute. And so we can say both conditions are true. And what this will do is it'll print out both conditions are true because num1 is less than num2, 2 is less than 3, and num2 is equal to 3. So both conditions are true. An OR statement looks like this, and it's if num1 is less than or equal to 2, or num2 is, let's say, equal to 4, which it isn't. But the overall condition will still be true because the first statement is true. So we could change that to 1 condition is true, right? Because it's this condition is true, or the other condition is true. So those are some of the basics of Java. Java is used in robotics, artificial intelligence, game development, app development, and so much more. It's really a useful programming language, and I hope to make another stream which we go more into depth with inputs and arrays and all sorts of things. So if anyone has any questions, please ask them. Cool. Just ask any question in the comments. I have some time. Great. I don't see any questions so far, but you can go to stempump.com-r-java. If you didn't finish, you didn't get what was going on, you can go to that, and it will give you a wide variety of resources, much more in depth than what I taught so far today. There's lots of examples, and it's really great for learning Java all the way through. I hope I can do another lesson, but yeah. So today we've completed the Java course. Right now on YouTube, you can find 3 courses for FTC programming, 1 course for web design, another course for Python, 3 courses for FTC judging, Figma, 2 courses for Inventor, one course for RPG Maker, and this, of course, will be on YouTube today. Coming up, we should have another artificial intelligence lesson that is coming up. I think that is very interesting, and y'all should go watch that. I definitely will be too. Cool. So go to stempump.com-camps to sign up for camps. Sign that QR code, take a screenshot, do whatever. STEMpump.com-camps to sign up for more camps. And download our app on the App Store. It's really great for getting lessons on the go. There's a lot of resources that you can access from your mobile phone. And you can go to stempump.com-r-YouTube to find this video of our camp and more on our YouTube channel. If you didn't understand what was going on, you can rewind, and it's all good. Add us on social media. At Discord at stempump.com-r-discord, and that will definitely so you can go to stempump.com-r-discord for any questions that you have relating to this. You can check our Instagram at STEMpump and our Twitter at STEMpump Texas. And please give your feedback. We would appreciate your feedback on today's camp. We would really appreciate that. So go ahead and do that. And thank you for joining our stream. I know I really appreciated doing this, and I hope everyone learned something today. Thank you.